So today we're going to discuss a stack and a heap. But let's start with the stack. What exactly is a stack? No, I'm not talking about that kind of stack, though I'm a fan of those stacks. You see, as developers, we're quickly inundated with the phrase stack from our earliest times. Stack Overflow, Stack Trace, Call Stack. But what is this mystical stack? I'm not talking about the data structure called stack. Instead, I'm talking about the way that your code is executed. For many of us, the first time we ran into this was in early debugging sessions when we were presented with a nested set of calls to see where a particular error came from. Like in this stack trace, it implies that something is keeping track of the execution path through our program. And this is true. This is what is called the call stack. It's really just a first in, last out chain of code. But there's something special in what we call a stack frame, or sometimes referred to as an activation record. This is where the code actually gets executed. As code leaves one stack frame and enters another, it's essentially paused while this new piece of code is executed. You see, as the stack adds frames, each stack frame has its own small but quick set of places to store data, in other words, variables. And if that code calls another piece of code, the whole process would be repeated. In most languages, the stack frame can only hold primitive values, things like numbers, booleans, and other simple values. The stack frame is small and quick, so it isn't big enough to hold large objects. But I'm getting ahead of myself. Let's talk about a really simple example. Here is a show method. It is simply passing some information, in this case an array, and then we're walking through that array to do something. This array is actually a reference, not a value type, but we'll get to that in a minute. Let's talk about the value types first. Locally, we can see we're creating a variable called x on the stack. It's a value type, so it can be stored in this very quick-to-access memory location. As we loop, we can change that value, but it's only accessible to us within this stack frame. And changing that value is very inexpensive. And when this code is finished, this variable just goes away. There aren't any long-term side effects from that local variable. Let's dig in a little deeper. Let's start with a console app that's just creating an object and calling its cook method. When we call this cook method, the stack frame is cached and stopped so that the new frame that is created can execute the cook method. In this cook method, we're creating a new reference type, again an array. This reference type isn't being created on the stack. Instead, it's created in a large pool of memory called the heap. The heap lives longer than the stack. When we call the show method, we're going to pass in that array. But what are we really passing? We're passing just a memory location to the object in the heap, not the actual object itself. What is a memory location? It's just a number. Therefore, the reference is a value type, a number, that can be stored on the stack, but it's really pointing at something in the heap. When we execute and go into the show method again, now we're in the show method again, and just like before, we create that variable that lives on the stack frame, and as we loop, we can change that value type. But once we do that loop, we can see that we can change the reference itself, and this change modifies that object in the heap. The object in the heap is going to live longer than the stack frame, therefore we're changing something that has state in other parts of our code. As we return from each method, the stack unfurls. The value type goes away with the frame. The entire frame is just gone. The x variable is released immediately because it's part of that stack frame. And as we close this next stack frame, no one will have a reference to that array any longer. So it needs to be cleaned up. So as this object goes out of scope,
some time later,
eventually, it is cleaned up, at least in memory-managed languages. In other kinds of languages, you'll need to do that freeing of memory yourself. But most of the viewers of this video will be using memory-managed languages or interpreted languages like JavaScript or Python. And as the program ends, the heap is removed as well. And sometimes that means that instead of cleaning up that object, it just destroys the whole heap when you close an application. What does this mean practically? I think you'll want to think about using primitives and value types whenever possible. Of course, this isn't always possible. But when you're thinking about how to deal with the difference between a reference type and a value type, keep in mind that the data local to the stack frame lives and dies with that stack frame. And that can be a blessing and a curse. can be a blessing in that you can create objects very quickly and destroy them very quickly. Don't forget to ask questions in the comment section, and I'll do my best to try and explain. I'll see you next time. I'm Sean Wildermuth.